Hi everyone, so let's continue on with the exponential function. Last time we looked at the exponential function in the form of y equals ab to the x power. Now we can actually use that to model an exponential growth or an exponential decay. Okay, so those are the two cases we'll look at. Alright, so let's first take a look at the exponential growth. Here again we have the y equals ab to the x. Now the a is the initial amount. Okay, so we'll call that the initial amount. It's what you start out with. And b is known as the growth factor. Okay, so b needs to be bigger than 1. Okay, and a needs to be bigger than 0, right, for this to be an exponential growth model. Alright, so here's an example of an exponential growth model. We'll look at population growth. So let's say, hypothetically speaking, on some planet it starts off with 12 million people, and every year it's going to increase by 5%. Alright, how can we use this equation here, y equals ab to the x power, to model this population growth? Well, we can write out y is equal to the initial amount is 12 million people, so the a is 12. And since it increases by 5% per year, the base, or the b, or the growth model, the growth factor, will be 100% plus the 5%, which will give you 105%, which is 1.05. Right, so 1.05 is the growth factor, or the b, and that's to the x power. So what we have here is a population growth model for this planet. Alright, so now let's take a look at an exponential decay model. Right, again we start off with the y equals ab to the x power. Now in this case, a is also greater than 0, but b is between 0 and 1. Just like before, the a is the initial amount, but now the b is no longer the growth factor, it is known as the decay factor. Alright, so here's an example of an exponential decay model. Let's say you bought a car for $10,000, and after each year it goes down 15%. So we'll use this y equals ab to the x to model this exponential decay. The $10,000 that you start out with, that's going to be the initial amount, which is a. And since it decreases by 15%, the b is going to equal 100% minus 15%, which is 85%, which is 0.85 as a decimal. Right? So that'll be the decay factor, or the b. Now we can write out the exponential decay function. Y is equal to the initial amount, which was 10,000, times 0.85, and raise that to the x power. Right? So now we can find the value of the car after x number of years. And we're done. And we're happy.